In addition to vertical and horizontal shifts or translations, we also have transformations that can be applied to the equation of the function that result in a reflection of the graph about both the x-axis and the y-axis. So let's look at the definitions for those reflections, and then let's talk about the working definition of how we can actually figure out what to apply and when. So the reflections about the x-axis. When the right side of the function y equals f of x is multiplied by -1, the graph of the new function y equals negative f of x is the reflection about the x-axis of the graph of the new function y of x. So reflection about the x-axis of the graph of the function y equals f of x. So what that is basically saying is that if the entire function is multiplied by a -1, then we're going to reflect the graph about the x-axis. When the graph of the function y equals f of x is known, and the graph of the new function y equals f of negative x is the reflection about the y-axis of the graph of the function y equals f of x. So if we have the entire function being made negative, it reflects about the x-axis. If only the argument of the function is made negative, then the graph reflects about the y-axis. So let's look at an example and discuss how do we decide if the entire function has been made negative or if just the argument has been made negative. And essentially it falls in the same category as our reflections, our shifts vertically and horizontally, if the negative is outside the sign of grouping. So signs of grouping are parentheses, square roots, absolute value symbols. If it's outside, then that is affecting the entire function. If it is inside, then it's affecting just the argument. So looking at our example here, we have f of x equals the square root of negative x. Well, the very first thing we have to do here in order to be able to sketch this graph is we have to figure out what is the parent function, and we have to sketch that graph. So in this case, the parent function would be the square root of x, because if we kind of take away all the negatives and the numbers that have been added and subtracted and that kind of thing, what we're left with is just square root of x. So we say that that's the parent function in this case. And if you remember, the square root of x started at the origin and it kind of went like this over to the right. And we can't go to the left because we can't plug a negative in, we can't get a negative out, that kind of thing. So now that we have the graph of square root of x, we're ready to apply our transformations in order to find the graph of the square root of negative x. So I see that I have a negative, and I know that this is going to be a reflection because there are no numbers involved. So it's not like I'm subtracting 2 or adding 2 or anything like that. I just have the negative there. So that tells me I'm working with a reflection, and the negative is on the argument, so that tells me that I'm going to be reflecting about the y-axis. Because remember, if the entire function is negative, it reflects on the x-axis, and if just the argument is negative, it reflects about the y-axis. So remember that this is our y-axis, and our reflection is just like a mirror. Think of it as if the y-axis were a mirror. What would the graph look like in that mirror? So another way of doing it is going, okay, so this is the point 1, 1. We can reflect that over here to where it's negative 1, 1. And we can use that to kind of give us a basis for our reflected graph. So because the negative is inside the radical, it's on just the argument, and that reflects the graph about the y-axis.